Welcome to PSR Tech Tutorials, where we simplify technology one step at a time. Don't forget to like, share, and subscribe to stay updated with our latest tech courses. Welcome to this quick guide on MLOps interview questions and answers. In this session, we'll cover the most important concepts, from supervised and unsupervised learning to deployment, monitoring, and evaluation metrics. Think of it as a structured preparation tool to help you revise fast and sound confident in your interviews. What is MLOps? MLOps is the practice of applying DevOps principles to machine learning projects. It helps manage the full life cycle of ML models, from data preparation to deployment and monitoring. Why do we need MLOps? ML models depend on both code and data, which change often. MLOps ensures models remain reliable, scalable, and easy to update in production. How is MLOps different from DevOps? DevOps focuses on software delivery pipelines. MLOps adds extra steps like handling data, experiments, and retraining models. Main stages of MLOps: collect and clean data, train models, deploy them, monitor and retrain when needed. This cycle repeats as data evolves. What is supervised learning? Supervised learning uses labeled data, input plus correct output, to train models. It has two main types of tasks: classification to predicting categories, for example, spam versus not spam, disease versus healthy. Algorithms, logistic regression, decision trees, random forest, naive Bayes, SVM, neural networks. Regression arrow, predicting continuous values, for example, house prices, sales forecasts. Algorithms, linear regression, decision trees, random forest regression, gradient boosting, neural networks. In short, if your target is categorical, use classification algorithms. If your target is continuous, use regression algorithms. What is unsupervised learning? Unsupervised learning works with unlabeled data, only inputs, no correct outputs. The goal is to discover hidden patterns, groupings, or relationships in the data. Clustering arrow, grouping similar data points. Algorithms, k-means, hierarchical clustering, DBSCAN. Association arrow, finding rules and relationships between items. Algorithms, a priori, FP growth, used in market basket analysis, for example, people who buy bread also buy butter. In short, unsupervised learning is used when data has no labels. Clustering groups data, while association finds meaningful item relationships. Difference between supervised and unsupervised learning? Supervised learns from labeled data to predict outcomes. Unsupervised finds hidden structures in unlabeled data. Examples of supervised algorithms: linear regression, logistic regression, decision trees, random forests, and neural networks. Examples of unsupervised algorithms: k-means clustering, hierarchical clustering, PCA, principal component analysis, and autoencoders. What is reinforcement learning? RL. RL trains agents to make decisions by rewarding good actions and penalizing bad ones. It's used in robotics, games, and recommendation systems. Difference between RL and supervised learning? Supervised learning uses labeled data, while RL learns by trial and error with rewards. RL focuses on sequential decision-making. What is an agent in RL? The agent is the learner or decision-maker that interacts with the environment to maximize rewards. What is an environment in RL? The environment is the system the agent interacts with. It provides feedback in the form of rewards or penalties. What is a reward function in RL? A rule that gives positive or negative feedback to the agent. It guides the agent toward desired behavior. What is accuracy? Accuracy is the percentage of correct predictions out of all predictions. It works well when classes are balanced. What is precision? Precision measures how many predicted positives are actually correct. High precision means fewer false positives. What is recall? Recall measures how many actual positives were correctly identified. High recall means fewer false negatives. What is the F1 score? F1 score is the harmonic mean of precision and recall. It balances both metrics, useful when data is imbalanced. Why use F1 score instead of accuracy? Accuracy can be misleading with imbalanced data. F1 score gives a better picture of performance in such cases. When should you use accuracy? Use accuracy when classes are balanced. It's not reliable for imbalanced datasets. When should you use precision? Use precision when false positives are costly. For example, spam filter marking important emails as spam. When should you use recall? Use recall when false negatives are costly. For example, missing a cancer diagnosis. How do you decide which algorithm is most suitable for your requirement? Answer: target type matters. If target is categorical, then classification algorithms, logistic regression, decision trees, random forest, naive Bayes. If target is continuous, then regression algorithms, linear regression, random forest regression, gradient boosting. Data size matters. Small dataset, then simple models, logistic regression, decision trees, naive Bayes. Large dataset leads to complex models, random forest, XGBoost, neural networks. Labels availability, labeled data to supervised learning, regression classification. Unlabeled data to unsupervised learning, K-means, PCA, clustering. Problem type, sequential decisions to reinforcement learning, Q-learning, policy gradient. Interpretability needed to simple models, decision trees, linear/logistic regression. Accuracy priority to ensemble/deep learning models, random forest, XGBoost, neural networks. What is overfitting? Overfitting happens when a model learns training data too well, including noise. It performs poorly on new data. What is underfitting? Underfitting happens when a model is too simple and fails to capture patterns. It performs poorly on both training and test data. What is bias in ML? Bias is when a model consistently makes errors in one direction due to flawed data or assumptions. It can lead to unfair or inaccurate predictions. What is fairness in ML? Fairness means ensuring models treat all groups equally without discrimination. It involves checking for bias in training data and predictions. How can bias enter ML models? Bias can come from imbalanced datasets, poor feature selection, or human labeling errors. It often reflects real-world inequalities. How do you reduce bias in ML? Use balanced datasets, fairness metrics, and bias detection tools. Regular audits and diverse data sources help too. What is naive Bayes? Naive Bayes is a simple probabilistic classifier based on Bayes' theorem. It assumes features are independent, which makes it fast and effective. Advantages of naive Bayes? It's easy to implement, works well with small datasets, and is good for text classification like spam detection. Limitations of naive Bayes? The independence assumption is often unrealistic. It may perform poorly when features are highly correlated. What is a decision tree? A decision tree splits data into branches based on feature values. It's easy to interpret and visualize. Advantages of decision trees? They handle both numerical and categorical data, are simple to understand, and don't need much pre-processing. Limitations of decision trees? They can overfit easily and become unstable with small changes in data. Ensemble methods like random forests help overcome this. How to avoid overfitting? Use techniques like cross-validation, regularization, pruning, dropout, or adding more training data. How to avoid underfitting. Use more complex models, add better features, or tune hyperparameters to capture patterns in the data. What is a true positive, TP? A true positive is when the model correctly predicts a positive case. Example, correctly detecting a disease when it's present. What is a false positive, FP? A false positive is when the model predicts positive, but the actual case is negative. Example, predicting disease when the patient is healthy. What is a true negative, TN? A true negative is when the model correctly predicts a negative case. Example, correctly identifying a healthy patient. What is a false negative, FN? A false negative is when the model predicts negative, but the actual case is positive. Example, missing a disease diagnosis. What is a confusion matrix? A table showing TP, FP, TN, and FN values. It helps evaluate classification performance beyond just accuracy. Why are precision and recall important? Precision focuses on correctness of positive predictions, while recall focuses on capturing all actual positives. Together, they balance model evaluation. What is cross-validation? Cross-validation is a technique to test model performance by splitting data into multiple trained test sets. It helps ensure the model generalizes well to unseen data. Why is cross-validation important? It reduces the risk of overfitting by testing the model on different subsets of data. This gives a more reliable estimate of performance. What is k-fold cross-validation? The dataset is split into k parts. The model is trained on k-1 parts and tested on the remaining part. This process repeats k times, and results are averaged. What is regularization? Regularization adds a penalty to the model's complexity to prevent overfitting. It discourages overly large weights in the model. Types of regularization: L1, lasso, shrinks some weights to 0, useful for feature selection. L2, ridge, shrinks weights evenly, reducing variance. Why is regularization important? It helps models generalize better by avoiding overly complex solutions. This improves performance on new data. When should you use cross-validation? Use it when you want a reliable estimate of model performance. It's especially useful for small datasets to avoid overfitting. When should you use regularization? L1/L2. Use L1 when you want feature selection, shrinks some weights to 0. Use L2 when you want to reduce variance and keep all features. When should you use pruning in decision trees? Use pruning when your tree is too deep and overfitting. It simplifies the tree and improves generalization. What is dropout in neural networks? Dropout randomly drops, turns off, some neurons during training. This prevents the network from relying too heavily on specific nodes. Why use dropout? It reduces overfitting by forcing the network to learn more robust features. It's especially useful in deep learning models. How does dropout work in practice? During training, a percentage of neurons are ignored in each iteration. At test time, all neurons are used, but with scaled weights. When should you use linear regression? Use it when the target is continuous, like predicting house prices, and the relationship between input and output is roughly linear. It's simple and interpretable. When should you use logistic regression? Use it for binary classification problems. Yes/no, spam/not spam. It works well when features and target have a linear relationship. When should you use decision trees? Use them when interpretability is important and data has both categorical and numerical features. They're easy to visualize, but can overfit without pruning. When should you use random forests? Use them when you want higher accuracy and robustness compared to a single decision tree. They reduce overfitting by combining many trees. When should you use naive Bayes? Use it for text classification tasks like spam detection or sentiment analysis. It's fast and works well with high-dimensional data. When should you use k-nearest neighbors, KNN? Use it for small datasets where decision boundaries are irregular. It's simple, but can be slow with large datasets. When should you use support vector machines, SVM? Use SVM when you have smaller datasets with clear margins between classes. It's powerful for classification, but less scalable for very large data. When should you use k-means clustering? Use it for unsupervised tasks like grouping customers by behavior. It works best when clusters are spherical and well separated. When should you use neural networks? Use them for complex problems like image recognition, NLP, or large datasets with nonlinear relationships. They need more data and computing power. What is data versioning? It means keeping track of different versions of datasets. This helps you know exactly which data was used to train a model. Why is reproducibility important? Reproducibility ensures experiments can be repeated with the same results. It builds trust and makes debugging easier. What is model versioning? Model versioning is like saving your progress in a video game or tracking changes in a Google Doc, but for machine learning models. It is the practice of assigning unique version numbers, like v1.0, v1.1, v2.0, to your models whenever you update them. Tools for data versioning? DVC, data version control, and Git extensions are commonly used. They help manage large datasets alongside code. What is a model registry? A central system to store and track ML models. It helps teams manage model versions and deployments in one place. What is model deployment? Deployment means making a trained model available for real-world use. For example, serving predictions through an API. Common deployment methods. Models can be deployed as REST APIs, batch jobs, or streaming services. The choice depends on business needs. What is containerization? Packaging models and dependencies into containers like Docker. This makes them portable and easy to run anywhere. Why use Kubernetes? Kubernetes helps scale ML models automatically. It manages containers and ensures high availability. What is CI/CD in MLOps? Continuous integration/deployment automates testing and releasing models. It reduces errors and speeds up delivery. Why monitor ML models? Because models can lose accuracy over time. Monitoring ensures they stay effective with new data. What is data drift? When incoming data changes compared to training data. This can reduce model accuracy. What is concept drift? When the relationship between inputs and outputs changes. For example, customer behavior shifts over time. How to detect drift? By tracking metrics like accuracy or comparing data distributions. Alerts can be set when performance drops. Tools for monitoring? Prometheus and Grafana for metrics, MLflow for tracking experiments. These tools help visualize performance. What is experiment tracking? Recording details of each ML run, data, parameters, metrics. It helps compare experiments and choose the best model. Tools for experiment tracking. MLflow, weights and biases, and Neptune.ai are popular. They provide dashboards for easy comparison. What is automation in MLOps? Automating pipelines for training, testing, and deployment. This reduces manual work and errors. What is a pipeline? A sequence of steps like data preparation to training, to testing, to deployment. Pipelines make workflows repeatable. What is hyperparameter tuning? Adjusting model settings like learning rate or batch size. Proper tuning improves accuracy and efficiency. What is a feature store? A system to store, share, and reuse features across ML models. It ensures consistency between training and serving. What is model governance? Rules and processes to ensure models are fair, ethical, and compliant. It's important for regulated industries. What is A/B testing in ML? Running 2 versions of a model in production. The better performing one is chosen for full deployment. What is rollback in MLOps? Reverting to an older model version if the new one fails. This ensures business continuity. Skills needed for MLOps: knowledge of ML basics, DevOps tools, Docker, Kubernetes, cloud platforms, AWS, Azure, GCP, and monitoring tools.